Okay, well, we'll kick off today's big issues in biodiversity science webinar series, and there are still a few people joining. So as they flow in, I'll introduce myself. I'm Owen Nevin. I'm the CEO here at WABSI, the Western Australian Biodiversity Science Institute, and thank you for joining us for today's big issues in biodiversity science webinar, where we're looking at some research conducted on impacts of solar photovoltaic energy developments on biodiversity conservation, bringing insights from around the world to share with you today. In opening our session, as we always do, and I'd like to acknowledge the traditional owners of the land that we meet on, and pay respects to elders past and present. And acknowledge that many people are joining from around Western Australia and further afield, acknowledging the traditional owners of the places you're joining from, but particularly I'm joining you from Borroloo, Perth, on the lands of the Whadjuk Noongar people, and paying respects to that. Here at WABSI, we are privileged to join into a long, many millennia of management of this land of Western Australia by the traditional owners, and bring our Western understanding to the traditional understandings of this place, and work to achieve better understanding and better management of this land together in a respectful way. WABSI is a joint venture. We have 10 organisations, 4 universities, 4 government departments, CSIRO and the West Australian Museum, working together in a partnership to really take on the big challenges for biodiversity in the state of Western Australia. We work in the space between the research community, government, industry, regulators, community and funders to really facilitate that collaboration and bring together strategic knowledge priorities for a sustainable future. WABSI takes a very end-user-led approach to our research prioritization and our program development, really trying to understand the knowledge needs that will help those working in environmental management or in extractive industries to better manage this place. All of our work is guided by the inputs of our end users and stakeholders, and on our website you can find our publications. The From Knowledge to Action Knowledge Priorities document is the most recent update of our key knowledge priorities that guide the work of WABSI, and working through those knowledge priorities to create programs of work and prioritize research strategies to address those knowledge gaps. So if you're new to WABSI, please visit our webpage and browse some of our research activities, our research programs. So today we're joined by Julia Gómez-Catasús from the University of Madrid, and without too much further, I will hand you to Julia, and we will do the magic changing over of my slides to yours if I can click on the right things. Julia, welcome.
Okay, thank you very much. I'm going to share the screen. Just let me know if there is any problem, or if you cannot see anything, or if the network connection is not working properly, because I cannot see you now, but just jump in if there is any problem.
We can see your slides clearly, and I'll just remind everybody that you can use the chat function to ask questions, which we will discuss at the end of Julia's presentation.
Okay. Okay, thank you. So good afternoon to everyone. Good morning from Spain. First of all, I wanted to thank the Western Australian Biodiversity Science Institute for inviting us to give this talk about our current research on the impacts of photovoltaic energy. I was supposed to be here with my colleague, David González del Portillo, but well, he had some personal issues and unfortunately he cannot be here today. But well, I will present like all the research lines that we have nowadays. And why do we focus on solar photovoltaic energy? Well, I guess that this figure doesn't surprise anyone in this room. It shows the impressive growth of main sources of renewable energy over the last years. And we can observe with the blue line that hydropower has been the dominant renewable energy source during years, but the graph also highlights the significant growth of onshore wind energy, which is in purple, and also of the photovoltaic energy, which is in yellow. And perhaps the most remarkable trend is the rapid expansion of solar photovoltaic energy, which has surpassed onshore wind energy in 2020 and also hydropower in 2023. So from our department at Autónoma University of Madrid, we work with these two sources of renewable energy trying to address the impacts of their infrastructures and also trying to apply different mitigation measures. But today I'm going to talk only about solar photovoltaic energy. And well, the benefits of this renewable energy are undeniable in the face of the climate change challenge. However, they also entail a range of environmental impacts that must not be overlooked. And the main problem is that this rapid expansion has surpassed the generation of knowledge regarding the environmental impacts, and creating critical knowledge gap need to be addressed. So this map illustrates the global distribution of solar PV energy, with darker green areas representing those regions with the highest cumulative capacity in 2024. I mean, it is not updated because this is the last graph that we can find in our working data, but I think it's useful just to have this global figure about the PV energy. So in this year, in 2024, Australia had an installed capacity of around 40 gigawatts, and well, the United States emerged as a key player with 176 gigawatts. On the other hand, we have Asia that has taken the lead, with India, China, and Japan alone accounting for more than 1,000 gigawatts. And in our case, in Europe, the total installed capacity reached around 330 gigawatts, reflecting the significant contribution to the global solar PV landscape. If we zoom in Europe, Germany stands as the leading country in terms of installed photovoltaic capacity with 90 gigawatts, and then it is followed by Italy and Spain with 36 gigawatts. So this is just to show you that within the European context, Spain, that is where we are carrying out our research lines, holds a substantial potential for solar energy, and it has experienced an impressive growth in recent years, with projections indicating continued expansion in the years ahead. So given this scenario, the Autonomous University of Madrid, in collaboration with the Forest Science and Technology Center of Catalonia and also with the support of Total Energies, launched the Step Forward Chair in 2022. And well, this chair, the primary goal is to generate and share scientific knowledge on the ecology and management of steppe birds, mainly, ensuring that their conservation is compatible with the expansion of PV energy. And why do we focus on step birds? Well, because most of the PV projects in Spain are sited on agricultural lands, and they pose a significant threat to step birds, mainly through habitat loss. And moreover, Spain serves as the stronghold for step birds in Western Europe and supports a substantial portion of their total European breeding population. And this group is already at threat, at risk of extinction. I don't know if you know about it, but well, so this is the reason why we focus mainly on this species and why we use it like as an indicator of the impact of PV energy. So the chair is based on these three interrelated lines of work. First, the research to generate scientific knowledge. Then we transfer this knowledge to the public and the private sectors, and then outreach to transfer the results to the scientific community and society. So our main focus today will be on the research activities that we have conducted or that we are currently carrying out at the university and also well, within the chair. But we will finish the talk with a brief overview of our knowledge transfer activities mainly. So first of all, we conducted a review of the current state of knowledge regarding the impacts of PV energy on wildlife and ecosystems. And we found this review particularly interesting because the primary challenge in the ongoing energy transition, as I mentioned earlier, is that the assessment of the environmental impacts and the implementation of effective mitigation strategies have not kept pace with the rapid growth of solar PV development. So our goal with this review was to consolidate the fragmented information on these impacts and to identify the methodological limitations and knowledge gaps that should guide future research efforts. So it was published in 2024, and of course it is becoming outdated very fast because a lot of research articles are emerging every year. But in any case, I wanted to briefly highlight the main results of our review. And well, I will explain later that we are continuously updating this information, and you can also have access to it. I will talk about that later. So, but what we observed in this review, I mean, first we found a total of 180 research articles, and well, the number of articles that have been published annually, of course, it has increased every year. But well, nowadays we have already around 280 articles, I think. As I said, I will talk about that later. And one of the most important results of this review is that when we compare the percentage of scientific studies with the installed PV solar energy capacity by region in the world, we observed that approximately 50% of the studies has been conducted in North America, specifically in the United States, despite the fact that it accounts for only 12% of the world's installed photovoltaic capacity. But however, other regions, like for example, Asia or Europe, with 59% or 21% of the solar PV capacity in the world, the percentage of studies on impacts and mitigation measures that have been carried out in this context drops to 16% or 21% respectively. So these results highlights the existing geographic bias on the knowledge about the impacts of PV energy, which concentrates the knowledge on arid and desert environments, mainly in North America, and this knowledge may not be transferable to other contexts, like for example the agricultural landscape that I was talking about at the beginning, where many of the PV infrastructure are installed in Europe and particularly in Spain, and which host significant biodiversity. So this geographic bias led led also to a bias in the habitats that have been studied. So most of the studies have been conducted in desert ecosystems that are mainly in Southern California. Then around 20% of the studies were carried out in our ecosystems and grasslands, and the remaining contexts were represented in less than 10% of the studies. And well, if we talk about the ecosystem components that were like the target to address these impacts, we observed that a significant proportion of studies address the impacts on abiotic factors, mainly microclimate or soil properties, and to a lesser extent on ecosystem services, around 4%, while the majority of the studies were focused on biotic components. So the interesting thing in this figure is that when we cross-reference this information, we observe that the knowledge about the different ecosystem components is not evenly based in all habitats or study contexts. So, for example, we observe that most of the information on reptiles come from deserts, but for example, there is not information in deserts about mammals. Then we can also observe that most of the information on arthropods comes from experimental designs, and this is mainly based on the studies on aquatic arthropods trying to see the impact of collisions against solar panels. We will talk about that later. But well, already with this figure, we can observe some knowledge gaps on ecosystem components and study context. And regarding the impacts, what do we know? Well, at the land scale, photovoltaic installation led to changes in land use, and this results in habitat loss and habitat fragmentation for different species. But they also have been shown to alter the microclimate at landscape scale, and it has been observed that they increase the temperatures during the night at around 3 to 4 degrees, and this is what it has been called as the heat island effect, that is similar to the heat island effect that we can observe, for example, in urban environments. And at thinner scale, PV panels intercept sunlight and modify the local distribution of precipitation, creating new shade and moisture gradients beneath the PV panels. And these changes can have cascading effects, influencing first the soil properties, and this will also affect the plant community, and then this at the end will alter the habitat at microhabitat scale, and this will have an effect on birds, arthropods, and bats. So therefore, these new shade and moisture conditions alter the microhabitat, and we will have both like winner and loser species resulting from this new PV ecosystem. And another effect associated with this infrastructure that I guess that you have already heard about this is the collision impact with photovoltaic panels, which has been observed in aquatic organisms, primarily in arthropods. And the problem is that the mechanisms underlying collision events are poorly understood. So the most discussed hypothesis is that aquatic insects might mistake solar panels as natural water bodies due to polarization of the light reflected, and they use this light to locate water bodies for laying their eggs. So this creates potential ecological traps, and this phenomenon has been called as the lake effect hypothesis. And well, in this study, we also aim to identify the main knowledge gaps, and to do so, we developed these two figures which compare the different environmental impacts of PV energy across different study contexts on the left side and climate on the right side. And we can observe that most of the studies address the impacts of PV energy on habitat loss or the alteration of the habitat at both landscape and microhabitat scales, and also on microclimate at microhabitat scale. So Yeah, and furthermore, you can see also here that a high proportion of the studies address land use planning, aiming to identify compatible areas for PV development and biodiversity conservation. But the problem is that as the number of studies per topic decrease, the context bias in current knowledge becomes more evident. So, for example, most of the studies addressing the impacts of PV energy on collision risks and microclimate at landscape scale have mainly been carried out in deserts and arid climates, and little knowledge exists about the potential of these agrivoltaic systems. So regarding the methodological aspects, it is important to highlight that 53% of the studies focus on a single PV facility, and only 2% of the studies use a WABSI design, a before-after control impact design. So this highlights the lack of standardized and robust sampling designs. Therefore, there is a need to use comprehensive WABSI designs that provide critical information on the direct responses of sensitive wildlife, and these studies should include multiple years and also multiple facilities, allowing for a long-term and large-scale analysis. And on the other hand, the employment of standardized protocols will allow these findings to be comparable across contexts, opening the way to more robust and generalizable results. So actually, within the Step Forward chair, we are working on designing these protocols, so that it will be interesting that in all the facilities in Spain, at least, they use them, and we can get all this information and then get more robust analysis. So these are the main findings of this review that we carry out, but before continuing, I wanted to let you know that all this information is available, and we have developed an online platform to provide access to all the information that has been compiled during this review. This platform, as I said at the beginning, is updated annually and is hosted within the Step Forward Chair website. You can access it with this QR code that you can see in the slide. And well, actually, as you can see here, it was updated in August 2025, and it will be updated again in September this year. For now, it has 280 articles. So from the review, we got 180 articles, but now there is more information available in this tool. And the tool consists of user-friendly search fields that allow to filter all the research according to the study context, the ecosystem component, the region, and other fields. And once you choose the desired fields, the platform generates this list of research articles, and each entry provides a brief summary of the main results and conclusions, and it also gives the link to the original publication. So to give you an example, if we use the platform to look for studies conducted in Australia, we find that based on our systematic search, this is the only Australian study we identified up to August 2025. It's essentially a case study rather than a broader assessment, which makes Australia a particularly interesting example of an important knowledge gap. Of course, this search is based on some keywords that maybe we have missed some important keywords. But as I said, okay, since August 2025, it has been not updated. It will be updated in September. But well, since I'm speaking to an Australian audience, if you are aware of any relevant study that we may have missed, we would be very grateful if you could let us know, and we will be delighted to include them in the next update of the database. Okay, so now I'm going to talk about other projects. For example, this is another project that we We already have finished it. I mean, we have already the manuscript and it is under review in Journal of Applied Ecology. But in this project, we wanted to address the impact of PV plants on nest predation rates. So as I previously mentioned, the solar installations create new habitats, and we can have winner and loser species from these habitats, and some bird species specifically, they can use them for breeding. So this is particularly true from ground nesting breeders, like for example, the steppe birds in Spain. Some examples are the stone curlews and other passerines such as larks, and because these species select open habitat to nest and raise their chicks. So, well, while these sites may provide these suitable breeding habitats, an important question remains, and is whether they also support successful reproduction or not. So this is why we wanted to address the impacts of these infrastructures on nest predation rates. And well, to understand how PV plants influence nest predation, this study evaluates three potential mechanisms. First, perimeter fencing that are installed in the in the border of the PV plants. This fencing may limit the access of some terrestrial predators, and on the other hand, solar panels may also provide shelter from avian predators. So together, these two mechanisms are expected to reduce nest predation within PV facilities. But on the other hand, we could also find that well-managed PV sites may attract predators by concentrating prey and other resources, and potentially they could create ecological traps for ground nesting birds. So under this hypothesis, we would expect a trap effect with higher predation rates inside PV facilities than in the surrounding control areas. So these contrasting hypotheses have been mentioned in the literature, but well, they have never been tested, and this is why we carry out this study. So we conducted the study across 5 PV plants in Spain. It was really difficult to find energy companies that wanted to collaborate also in the project, but at the end we got 5 PV plants and we placed 540 artificial nets, and they were deployed in 2 periods. So at the beginning of the breeding season around April, and also at the end of the breeding season around late May, early June. And well, the nets were monitored after 14 days exposure. These pictures that you can observe here is a real nest that we found in the field in a PV plant. This is the stone curlew that I mentioned before. But well, we carry out the study with artificial ground nets because of course it was not feasible to find so many real nets. And well, we follow a control impact design, and we place the artificial nest both inside each PV facility, but also in control areas that were close by and that have similar vegetation structure to the one that we found inside the PV plants. So in both contexts, nets were located at 2 distances to the border, so at the margin and also at the center, based on the expectation that predation risk is generally higher near the margins in both within the PV plant, but also in control plots. Okay. And then within the PV plants, nets were also placed in 2 microhabitats beneath the solar panels and also in the interval zone between panels. So this design allows us to test whether PV facilities act as barriers that limit the access by terrestrial predators, but also to test whether the panels themselves provide shelter from avian predators. Well, each artificial nest contained 3 common quail eggs. There were 2 real eggs, and then one of the eggs was filled with plaster, and this was to allow the identification of predator species through bite marks and other traces. And then the plaster-filled egg was fixed to the ground just to prevent predators from removing it. And we also placed some camera traps, not in all the nests, but in some of them, just to to have more information about the predator identity. But in the other nests, we just classified as avian or terrestrial predators. And turning to our results, we found that 60% of the artificial nests were predated within the 14-day monitoring period. However, predation rates vary markedly over the breeding season, so increasing from 48% at the beginning of the breeding season to 72% at the end of the breeding season. And this could be because higher predator activity is expected at the end of the breeding season due to post-breeding adults and dispersing juveniles. And when we examined the effects of nest location, we found two main patterns. So first, there was a clear age effect. So throughout the season and also across all sites, we found that nests located at the margins consistently experience higher predation than those in the center. So here in margin, you have the red boxes and the center is the blue boxes. So you can always see this increase in nest predation rates. Then we found evidence of a solar panel effect. So nests that were placed beneath the solar panels consistently experience lower predation than those in control sites. So for example, the reduction was approximately 6% during the early breeding season and increased to around 20% later in the season compared to the control. And a similar, although weaker, effect was observed for the interval zone. So also there was a lower predation rate than in control areas, but well, this was marginally significant, this effect, and well, the reduction was traduced in around 4% reduction against the control during the beginning of the breeding season and around 14% at the end of the breeding season. In this study, we also accounted for differences in landscape composition and vegetation structure, but well, we tried to control for differences because we were mainly focused on these effects. And well, neither variable had a detectable influence on predator probability. And then finally talking about the predator identity, out of the 326 nests that were predated, we couldn't identify the predator in 56% of the nests, and this was because, well, the egg that was filled with the plaster, it was useful sometimes, but we couldn't be sure about the predator in all the cases. But what we found is that from the other nests, the other 46% of the nests, around 26% were predated by birds and 18% were predated by mammals. And these are the pictures from the camera traps of the main predators that we found in the study area. Well, as I said, this study is under review now in Journal of Applied Ecology, but now I'm going to talk about other projects that we are carrying out today, but we don't have results yet. This is one project where it's focused on the spatial ecology of these 6 steppe bird species: the little bustard, the Eurasian stone curlew, the Montagu's harrier, the lesser kestrel, and both the pintail and the black belly and grouse. Well, all of them are steppeland birds that are typical of this open agricultural landscape and which now share their habitat with these PV facilities. So since the beginning of the project, we have GPS tagged a total of 65 individuals, and we are trying to understand how they use this shared space with the PV energy. For instance, well, thanks to this GPS telemetry data, we have mapped their breeding, summering, and wintering grounds, as well as their migratory routes, and we have even recorded several nesting events inside the PV facilities in the case of the stone curlew. I mean, you can see here in this graph clearly how they use these facilities. And well, what we do in this study is that we evaluate the behavioral responses of these 6 European steppe bear species to the expansion of PV infrastructure by analyzing this high-resolution GPS tracking data. And what we do also is that we characterize the environment and we use variables like, for example, the PV plant size and also the surrounding land uses that we can find in the landscape. And then what we are going to do in the coming months is to quantify the responses at 2 complementary spatial scales. So first by analyzing the landscape scale patterns of space use, and then secondly by analyzing the fine scale movement decisions. And the last project that I'm going to present today is another key project of the chair, and is testing this lake effect hypothesis that I mentioned earlier. So this phenomenon, as I said before, has already been documented in other taxa, mainly in aquatic arthropods, because it has been observed that they tend to lay their eggs on solar panels, mistaking them for water bodies. So a similar effect has also been suggested for aquatic birds and even bats, but it has never been proven. So in particular, nocturnal migratory birds rely on water bodies as stopover sites for resting and also for foraging during migration. And if they mistake also these PV plants for water, they may also be attracted to these facilities at night. So to investigate this effect, what we are doing is that we are following a WABSI design before after control impact, and we have deployed autonomous recording units like this one that you can see in the picture. And they have been located along a gradient extending from the center of the PV facility to control areas outside the plant. And well, these devices record audio throughout the night, and we will use automatic recognition software to identify the species passing through the area, as well as the intensity of bird activity measured by the number of recorded calls. And well, we are currently conducting the field work, and also during the coming months we will analyze this data set to identify any potential ecological effects. Well, I will briefly talk about the transfer activities that we are carrying out. So as part of our commitment to transfer the academic knowledge into practice, we have published these 2 comprehensive handbooks that you can find in the QR code. And first one of them provides practical evidence-based guidelines for designing next boxes programs, because I don't know in Australia, but in Spain, a lot of compensatory measures include the installation of these next boxes, but well, sometimes it's done okay, but other times it's not okay. So we are just providing this information. And then the second handbook is based on just to define some methodological protocols to standardize the environmental surveillance at solar facilities. And furthermore, we are now developing a third handbook that is especially focused on fallow land management, aiming to optimize these crucial habitats for steppe birds in Spain. And other activities that we do to transfer the knowledge to all the stakeholders are this Step Forward Technical Conference. That is we do one every year, like since 2022. It's usually in November. And well, what we want is to involve all these stakeholders, including researchers, industry companies, and public administrations. And well, this conference features case studies on specific species alongside roundtables that give attendees the opportunity to engage in open debate. And we are currently organizing our next edition that is usually in Spanish. Last year it was in English also, and we had the translation at the same time. But well, if you are interested, of course you are warmly welcome to come to the University of Madrid. And well, although I'm only here today, as I said, David, it was my colleague that was supposed to be with me here today, but he couldn't come. So, but this is like the team that we are representing, and this project is the result of the hard work and dedication of these researchers and colleagues that are back at the chair. So yeah, thank you very much.
Thank you, Julia. That was an excellent presentation and some really good insights as you went through there. And I'll just remind our participants that you can drop questions in and comments into the chat function to inform the direction that we take the conversation over the next few minutes. But just a few things to touch on, Julia, while people drop some questions into the chat. You mentioned that you've developed some standardized monitoring protocols, and one of my questions was going to be, are those available? You told us they were through your the manuals that you developed. Are those in Spanish, or are those available in multiple languages? Yeah.
Yeah, that's the problem, that they are in Spanish. They are available in this QR code. I mean, if not, I can share with you. If you write a step forward chair in Google, you can find the website, and there you can find like this transfer activities, and these handbooks are available there. But yeah, the problem is that they are in Spanish, but I think that they will be translated into English. So yeah. Maybe they will be available, or if not, maybe you can help with any kind of translator, but this is one of our aims, to translate it at some point.
Yeah, excellent, thank you. And the other question that I had was about your portal for that summarizes the peer-reviewed papers that are available looking at this topic, and with the very strong. Oh, getting some feedback. Not sure why I'm getting feedback there. With that portal, is that an automated process, or do you have a team that is reviewing those papers and adding them in?
Yeah, no, it's not automatic. Actually, we have to, I mean, we have these keywords that we use for the review, so we get the alerts of the manuscript that are published like every day with this information. And yeah, we have to read them and then classify them according to the different categories, and then we just put them in the platform. And that is the reason why we only do it like once per year, and it's usually around September, because of course it takes a lot of work from the people that is doing it, and they have to read it.
Okay, thank you. We've got a question here around the nest trials that you did, asking whether the placement of the nests in your experimental trial, was that representative of what would be a naturally occurring sort of nest density, or were they more dense, less dense?
No, actually, I don't think so. Yeah, this is one of the limitations that we argue in the discussion of the article, because, of course, we are using artificial ground nests. That is the first problem, and of course, they don't have the role. I mean, the parents there to defend the net. So the predation rates that we observe, they must be higher, and then also the density of the nets, because they were at distances of around 50 meters, more or less. Well, we don't really know what is the density of nets in the study area, but of course, I guess that it should be lower. But well, I think that in any case, although we cannot trust the absolute values of predation rates, I guess that it is useful at least for comparing the relative abundance, predation between the different treatments, like beneath the solar panels, in the interval zone, and the control areas.
Yeah, and I think that use of an elevated density of nests to be able to look at difference. If you're putting out nests at a naturally occurring density, it might be very challenging to actually get statistically robust results.
Yeah.
in there.
Yeah.
Just looking at the other questions. Yes, Matthew, you asked about the public, whether the presentation will be available, and it will. All of our webinars are available through links on the WABSI website, and we have a YouTube channel where those are. I'm just looking at to the question around remote sensing and landscape scale monitoring to help identify low biodiversity impact areas for future projects. Have you had any involvement with that sort of landscape scale planning and the use of remote sensing techniques to prioritize low biodiversity sites for solar PV?
Well, from the chair, we have not done that, but I know that there are other teams that they are doing things similar in Spain to use this information from the GPA's data to contribute to this land use planning. But no, from the chair, we are not doing it now.
Yeah. And within your group, are you doing any work on changes in vegetation structure or plant species occurrence for the shading impacts?
Yeah, one thing that we want to do, but I mean, and we are talking with different companies to try to do it, is to apply different methods of vegetation treatment and vegetation management, and try to see the effects that these have, like in different aspects of biodiversity, like for example pollinators, well, arthropods, also small mammals and even birds. But well, this is, I mean, I haven't talked about that because we are not doing anything about it yet, but we would like to try with different kind of treatments, like for example to introduce the seeps that I don't know in Australia, but here in Spain commonly they go into the PV plants and they eat I mean, there are like agreements between the PV energy companies and the landowners in the area, and they go with the seeps inside the PV plants just to manage the vegetation. But we would like to try this treatment against other treatments that are commonly used and try to see like the different effects on biodiversity and try to have like these win-win solutions for biodiversity, but also to minimize the losses on PV energy and these kind of things. But I mean, this is just something that is starting to go, but we are not doing anything yet.
And have you seen any impact on design changes based on your your completed work, or is it still early in that process working with the companies?
Yeah. You mean about the design of the PV plants, and the different? Yeah. No. I mean, with the GPA's data that we have on birds, we want to test at least the effect of the PV size, and we will try to also assess the effect of other characteristics of the PV plants. But we don't have results on this project yet, so we have to analyze the data.
Yeah, very good. And one of the things that we often think about here in Australia and Western Australia in particular around renewable energy projects is the introduction of new linear infrastructure into the landscape, and how that can potentially have impacts on movement of feral and invasive animals and propagation of seeds through the landscape. Is that something that you've seen, or are these mostly going into agricultural landscapes that already have fairly extensive linear infrastructure?
You mentioned that you are worried about the effect of these lines on what exactly? I didn't understand that part.
Invasive species. So in your photographs, you had some terrestrial predators there, including fox and wild boar, both of which are non-native here in Australia, but are established as pests. Whether you're seeing increased movement.
Yeah, okay. Yeah, I mean, we are not working now with these transmission lines, but of course they are associated with all this project, and we agree that it's also an important concern about, I mean, the impacts that it has on biodiversity. But well, we know about other groups in Spain and also in Portugal, in the Iberian Peninsula, that they work with the impacts of these transmission lines. And well, of course, they also have impacts on this kind of species, although there are already transmission lines in the landscape. New lines are being introduced and they create collision, mortality of individuals, electrocution, and all these impacts, the fragmentation of the habitat. So yeah, I mean, we are not addressing them, but a lot of research groups here in Portugal or Spain, they are working with that part.
Excellent, thank you. And we have a participant joining us from Kenya. Welcome, Dominic, and thanks for joining the webinar from Africa. And great question around, do you know of any studies or plans for studies to move into emerging markets like the expanding African market for EV?
No, I don't really. No, sorry.
Yes. Yeah, but yeah, some great opportunities for studies and for comparative studies in that space. Yeah. Well, thank you so much, Julia, for your presentation. And while I thank you, I'm just going to put up a slide that has another QR code on it, a QR code to feedback questionnaire around our webinars to help us to improve the webinars. That asks that participants take a few minutes just to have 5 quick questions that you can answer to give us some feedback and guidance on future webinars and webinar topics. Also remind you that today's presentation and the recording of the discussion will be available on our YouTube channel that you can link to from the WABSI website, and look out for information on upcoming webinars which will be shared over the coming months. Thank you, Julia, for a really interesting presentation, some really good work there, and good opportunity to see what we can learn as we move into increasing photovoltaic here in Western Australia. So thank you once again for your participation and willingness to share with us today.
Yeah, thank you very much for the invitation, really. Yeah.
Thank you.